Good morning, friends. Welcome to JEE Telugu Mantra. Today we will discuss about the new topic, calculus. In the calculus, the first part is limits. First, you know about the calculus. Suppose you have a brief idea about the limits. You take in our daily life examples. Suppose you take a human being. ఒక మనిషిని మనం తీసుకున్నప్పుడు ఆ ఎదుగుదల అనేది మీరు గమనించలేరు. ఇప్పుడు మీరే చిన్నప్పుడు ఉన్నారు, ఒక 0 వయసు ఉన్నప్పుడు మీరు కొంచెం చిన్నపిల్లవాళ్ళలాగా ఉంటారు. 1 year అయినప్పుడు కొద్దిగా పెరుగుతారు, 2 years అయినప్పుడు కొద్దిగా పెరుగుతారు, 3 years అయినప్పుడు ఇంకొంచెం పెరుగుతారు. ఇయర్ బై ఇయర్ మీరు చూసుకుంటున్నప్పుడు మీ యొక్క పెరుగుదల అనేది మీకు తెలుస్తుంది, ఎంత హైట్ పెరిగాను ఏంది అనేది. సపోజ్ నేను ఎంత పెరిగాను అనేది నాకు ఒక సెకండ్లో కావాలనుకోండి. ఇప్పుడు నేను మామూలుగా పుట్టాను, ఇప్పుడు ఈరోజు పుట్టాను, ఒక 5 hours ఎంత పెరిగానని తెలుసుకోవాలి. మీరు తెలుసుకోగలరా? లేదు, 10 hours ఎంత పెరిగానని తెలియాలి మీకు. తెలుసుకోగలరా మీరు? అంటే ఇవన్నీ ఎలా ఉంటాయంటే పెరుగుతాం కానీ మనకు తెలియదు. డైలీ మనం పెరుగుతూనే ఉంటాం. మీకు తెలుసా ఇప్పుడు ఎంత హైట్ వచ్చారో, మీరు ఎలా హైట్ వచ్చారో మీకు కూడా తెలియదు. ఆటోమేటిక్గా జరుగుతూ ఉంటుంది అది. లేదు, ఇంకో లైవ్ ఎగ్జాంపుల్, ఒక చిన్న మొక్కను తీసుకున్నారు, దాన్ని ఒక కుండీలో పెట్టి చక్కగా నీళ్లు పోసారు. 1 గంటలో ఎంత ఎదిగింది, ఒక 2 గంటల్లో ఎంత ఎదిగింది, లేదు ఒక ఫ్రాక్షన్ ఆఫ్ సెకండ్స్లో ఎంత ఎదిగిందని మీరు తెలుసుకోగలరా? సపోజ్ ఒక 5 నిమిషాల్లో ఎంత ఎదిగింది అని తెలుసుకోవడానికి, అంటే నిజానికి పెరుగుతుంది కానీ ఎంత పెరిగింది అనేది మీకు తెలియదు. దాన్ని ఇన్ఫైనిటెన్షియల్లీ స్మాల్ అంటాం. అంటే చాలా మైన్యూట్ లెవెల్లో పెరుగుతుంది. ఏదైనా సరే, అది ప్లాంట్ అయినా హ్యూమన్ బీయింగ్ అయినా ఎవరైనా సరే పెరుగుదల అనేది జరుగుతూ ఉంటుంది. బట్ ఫ్రాక్షన్ ఆఫ్ సెకండ్స్లో ఎంత పెరిగింది అని తెలుసుకో, అంటే మనం పెరుగుతున్నాం కానీ ఎంత పెరిగాము అనేది ఇన్ఫైనెట్లీ స్మాల్, అంటే చూడడానికి చాలా చిన్నదిగా ఉంటుంది అన్నమాట. ఈ కాన్సెప్ట్స్ మీద మనం ఈ డిఫరెన్స్ని ఏమంటామంటే డిఫరెన్షియల్ క్యాలిక్యులస్ అంటాం. క్యాలిక్యులస్ అంటే జస్ట్ క్యాలిక్యులేషనే, ఈ డిఫరెన్స్ క్యాలిక్యులేట్ చేయడం. ఇది మనం ఫంక్షన్స్లో అప్లై చేయాలి. ఇంతకుముందు మనం ఫంక్షన్స్ నేర్చుకుని ఉంటాం కొన్ని కాన్సెప్ట్స్. ఈ ఫంక్షన్స్లో డిఫరెన్షియల్ ఎలా వస్తుంది, ఈ చిన్న డిఫరెన్స్ ఇన్ఫైనెట్లీ స్మాల్ అనే డిఫరెన్సెస్ ఎలా వస్తుంది. జనరల్ లిమిట్ అంటే మీ ఉద్దేశం ఏంటంటే హద్దు అని, జస్ట్ హద్దు అంటే రీచ్ అవుతున్నాము, అంతవరకు రీచ్ అవ్వాలి, అనేది చాలా ఇంపార్టెంట్. ఇట్ టెన్స్ టు రీచ్ అంటే అంతవరకు చేరాలి అనేది మనకు అర్థం. ఇది లిమిట్. ఈ లిమిట్ కాన్సెప్ట్ ఐడియా మనం చూద్దాం. ఈ క్యాలిక్యులస్ ఈజ్ వెరీ వెరీ ఇంపార్టెంట్, పవర్ఫుల్ చాప్టర్ డెవలప్డ్ బై లైబ్నిజ్ అండ్ సర్ ఐజాక్ న్యూటన్. నెంబర్ ఆఫ్ ప్రయోగాలు చేసిన మీదట ఈ డిఫరెన్షియల్ క్యాలిక్యులస్ మనకు తర్వాత వస్తుందండి. డిఫరెన్షియల్ ఎలా చేయాలి అనేది తర్వాత వస్తుంది. ఫస్ట్ యూ నో అబౌట్ ద కాన్సెప్ట్స్ ఆఫ్ లిమిట్స్. లిమిట్స్లో మీకు చెప్పిన ఎగ్జాంపుల్స్లో మీకు బాగా అర్థమైంది అనుకుంటున్నాను. అంటే మనం ఏదైనా ఒక చేంజ్ కోరుకోవాలి అంటే, ఒక చేంజ్ ఇన్ ఫ్రాక్షన్ ఆఫ్ సెకండ్స్లో ఒక చేంజ్ రావాలి అంటే అది నిదానంగా రీచ్ అవుతుంది. ఇట్ సీమ్స్ టు బి రీచ్ బట్ ఇట్ ఈజ్ నాట్ రీచ్. మీకు ఎదుగుదల అనిపించదు కానీ ఎదుగుదల వస్తుంది. ఇట్ సీమ్స్ టు అనమాట, టెన్స్ అంటే అనిపిస్తుంది. అలాంటి కాన్సెప్టే మనకి లిమిట్స్. ఇప్పుడు మనం ఒక ఫంక్షనల్ టాపిక్స్ దీనికి రిలేటెడ్గా తీసుకున్నప్పుడు, if you take x is a variable, fx is a function. If x is increases, automatically fx is increases. The variable value is increases, fx is also increases. But our concept is, if we increase infinitely small. Suppose I take the variable x is a variable here. Delta x is a small change in the variable x. Delta means a small change in the variable x. And now y is equal to fx is a function. Y is equal to fx is a function. If I change the small notation in here, y plus delta y, and small change in x, x plus delta x. Now y is equal to f of x plus delta x minus delta y. A small change occurred. Suppose if x is a variable, if you give one value of x, then fx automatically changes. Now, you take a circle. What is the limit of the circle? If I take one secant line here, what is the limit of a secant line? ఈ లైన్కి లిమిట్ ఎక్కడ దాకా ఉంది? మహా అయితే ఈ లైన్ మనం సర్కిల్ ఎండ్ వరకు తీసుకురాగలం. సర్కిల్ బయటకు తీసుకెళ్ళంగా. ఇఫ్ ఐ డ్రా ఏ సెకండ్ లైన్ లైక్ దిస్, again like this, finally the secant line touches the circle. It does not comes to the outside of the circle. That means the limit of a secant line be a tangent. Finally we conclude that if you draw a line, secant line, smaller to smaller, then the final secant line is just, it touches the circle at only one point. That should be a tangent. Now the limit of a secant line is a tangent. Now you take another one by taking variables. Suppose this is small a, this is the right side of small a, this is left side of small a. If you increase the value from a to right side, if you take a plus, if you are taking the value from the left side, it is a minus. Limit extends to a, f of x is equal to, suppose you take it as L. Limit extends to a, f of x is equal to L. That means if x value reaches to a, then function value reaches to L. The previously discussed, if x changes, fx value is also changes. If x tends to a, it is not reached to a, not x is equal to a. If x tends to a, then fx value reaches to L. The same notation here, x a here, x not equal to a. If you take the right side, it is a plus, and it is left side, it is a minus. A small change in right side, a small change in left side. How much the function varies if x tends to a, not x is equal to a. Suppose we take one example here, limit x tends to 2, x square minus 4 by x minus 2. X square minus 4 by x minus 2. If x is equal to 2, 2 minus 2, it is equal to 0. Anything by 0 is infinity. But I didn't take x is equal to 2. The meaning of x tends to 2 is, if x tends to 2 means x reaches the value 2, not equal to 2. Now you don't substitute in the x value. Suppose if you take the right side of, suppose I take here 2, if you take right side here, limit x tends to 2 plus x square minus 4 by x minus 2. 2 plus means right side, positive values. Left side is negative values. Here, if you take limit x tends to a plus, then fx is equal to what? Here, limit x tends to a minus, fx is equal to what? Then x is equal to a, what is the value of function? Then it is a limit existence. You simply observe that limit is in the case of tends to a, not reaches to a, reaches to a. Please understand the situation. That means when a limit existence means right side function value and the left side function value you have to find out. Then both are equal, limit is exist. See, if you observe this example, 2 plus in the sense 2.01 or 2.001, 2.0001, infinitely small values we observe in the starting, we discuss it. If you take 2.01, here it is 4.01. If you take 2.001, 4.001, slightly increases. If you take right side value, 2 plus means 2.01. If you take infinitely small, the starting fundamental limits you discussed, no? Infinitely small changes, then automatically fx value also changes. It is also 4.01. If you take 2.001, we get 4.001, infinitely change. If you take 2.0001, 4.0001. If you take left hand side also, limit extends to 1.99 or limit extends to 1.999 of fx value. If you substitute in the function x square minus 4 by x minus 2, now it's very nearer 3.99, 3.999 like that, not equal to 4. If you take from right side, nearer to the value 4. If you take side the left side, nearer to value 4. If you take the right side also, just increases 2.01, nearer to 4.001, nearer to 4. Directly we substitute here x is equal to 2 means 2 square minus 4 by 2 minus 2 should be 0 by 0 form. Generally, we take the value by taking factorization. X plus 2 into x minus 2 by x minus 2. Now x minus 2 cancel. Limit x tends to 2. X plus 2 value is 4. This is direct. Don't substitute here. Because if you substitute in the value of the function, it is in the form of 0 by 0. Next coming videos you should know about the 0 formations. Now this is one idea of the limits. The idea should be, when you take the right side of the functions and the left side of the functions, the value is reaches to the value, it tends to a, not equal to a. That is the limit of the concepts of a limits. It seems to be neighborhood also. Neighborhood means if you take x is equal to x tends to a, f of x is equal to L. If you take a neighborhood in the sense limit x tends to a minus means if fx value is a minus h, h is infinitely small value, left side. If you take x is equal to a plus f of a plus h, you have to find out. That means in the place of the function, if you substitute a minus h when x a minus, if you take f of a plus h, suppose here fx is equal to x square, that the value is a minus h whole square. Here the value is a plus h whole square, where limit x tends to a minus and limit x tends to a, because already a minus in the sense a minus h, a plus in the sense right side. That means the changes a minus means in the place of x we write a minus h, because infinitely small value already we understood here. If you take from right and left, the h is the infinitely small value. If you take here the previous example 2, is it 2 plus 0.1, 2 plus 0.001 like that. That is h. That means 2 plus h. Here 2 minus h. In the same you take here a, this is a plus h and this is a minus h. These are called the neighborhood of the limits. If you apply 2 plus means 2 plus h. If you apply 3 minus means 3 minus h. Like that we substitute in the place of x when they have to find out in the step functions and the fractional type of functions, then we apply the neighborhood of the limits. Limit existence also one of the important. Limit existence. We in the previous example, when limit exists, we know limit x tends to a minus f of x is equal to limit x tends to a plus f of x is equal to L value. That means neighborhood of both a minus and a plus are equal, then limit should be exist. In the problems they are given in the NCERT, mainly in NCERT they are given when the limit exists, what is the value of x? When the limit exists, when the both roots are given, find the quadratic equation like that. Or whenever the conditions are given x less than 2, 2 less than x less than 3, when a function is given, if we substitute in that given function, when the limit exists, we find the values of x and y. Of the limit existence also very important. Right. The problems are very easy regarding limits. It has 2 or 3 types. One is the direct procedure we have to apply. That means a function is given or a polynomial is given, directly substitute the value f. That is one of the important model. And the next one model, suppose if you substitute the x value, the denominator is 0. The denominator is 0. How can you solve when a polynomial is given? Like previous example, x square minus 4, x plus 2 into x minus 2. That is one of the method. But various types of methods. Various types of methods. The first one is, it is a polynomial is given. Polynomial is given, that means limit x tends to 2x square plus 3x is equal to, now in this case directly we substitute the value 2 into 2 square plus 3 into 2, that is 8 plus 6, 14. This is direct position. Or if you take here limit x tends to 2x square plus 3x by x plus 2, this should be also direct procedure. Whenever the denominator is not equal to 0, when you substitute x value, directly we have to substitute the x value, we get the answer. This is the first method. In the polynomial case, the second method is limit x tends to 3, x square minus 9 by x minus 3. X tends to 3, x square minus 9 by x minus 3. Now we substitute here 3 minus 3 is equal to 0, 3 square minus 9 also 0, 0 by 0 is indefinite form. Like this indefinite form we have to observe, we take factorization methods. A square minus b square, that is a plus 3 into a minus b by x minus 3, x minus 3 cancel, limit x tends to 3, x plus 3, that is equal to 3 plus 3, it should be 6. This is a normal procedure. Whenever a polynomial is given, if the denominator is not equal to 0, then direct substitution. If denominator, if we substitute 3 is equal to 0, then direct substitution's value. And anyway the denominator is 0, we take the factorization methods. The second one is rationalization method. Rationalization method. Rationalization, suppose if you take limit x tends to 0, root of 1 plus x minus 1 by x. Whenever roots are given in the numerator and denominator, if you substitute x is equal to 0, again it is 0 by 0 formation. In that we take rationalization. It is 1 plus x minus 1 by x into root of 1 plus x plus 1 by root of 1 plus x plus 1. Now in the numerator, a minus b into a plus b, a square minus b square by x into root of 1 plus x plus 1. Now 1 cancel, x cancel, 1 by root of 1 plus 0 plus 1, that is equal to 1 by 2. This is the rationalizing factor. Whenever rationalizing method, whenever the square roots are there in the numerator and denominator, then you can take the factor rationalization method. Sometimes both the numerator and denominator both are square root parts. You take 2 times rationalization, we get the answer. This is the second method, rationalization method. And next, L-Hospital method. L-Hospital method. L-Hospital method means limit x tends to a f of x by g of x is equal to limit x tends to a f dash x by g dash x. Whenever the denominator and the numerator is both are zeros, just we take factorization, that is the one procedure. Whenever it is not possible, we take the differentiation of numerator and denominator, we get the answer. Suppose you take x is equal to 2, x square minus 4 by x minus 2, the differentiation part. Here 2 minus 2, 2 square minus 4 already 0. If we take differentiation here, 2x differentiation, 2x differentiation 2 and x is differentiation 1. Whenever the functions both fx and gx are given, the L'Hospital means differentiation method. If you take numerator and denominator differentiate, we get the answer. That is L'Hospital method. And one more important concept, that is indeterminate form. Indeterminate form. Suppose in the case 0 by 0 or 0 by infinity or infinity into infinity or 0 to into infinity, 1 power infinity or infinity power 0, like that, these are all called indefinite forms. Here infinity is not a number, just it is a symbol. It is not a number, it is a symbol. Then you have to find out limit x tends to infinity, like that. Infinity plus in the sense of if you take positive values. If you take positive values, limit x tends to infinity minus negative value, but it is not meaningless because infinity just is a symbol, it has a number. That means these two are the meaningless whenever x tends to infinity is given. Very important. Whenever x tends to infinity is given, 1 by x tends to 0. This is very, very important. 1 by infinity is equal to 0, but it is not equal to 0, it tends to 0. 1 by infinity is tends to 0, it reaches to 0, it is not equal to 0. కాబట్టి ఈ ఇన్ఫినిటీ అనేది జస్ట్ ఒక సింబలే, ఇది నెంబర్ కాదు. దీన్ని మనం ఎలా కూడా ట్రీట్ చేయాల్సిన అవసరం లేదు. Infinity in the sense the numbers are increasing up to all positive, maximum positive integers. Here x tends to negative infinity means that wherever the negative highest number to infinity, whatever the value is given, it is purely as a negative values, it is positive, but infinity plus and infinity minus are meaningless. Whenever a limit extends to infinity is given, 1 by infinity tends to 0. If you take the value 1 by x tends to 0, that is very important because in NCERT number of problems are given. JEE Mains and Advanced, after the theory we discussed the problems of x tends to infinity. Suppose you take one example, limit x tends to infinity 2 plus x by 3 plus x. But x tends to infinity 2 plus x by 3 plus x. I want to take x is equal to x tends to infinity. Whenever x tends to infinity, we know that 1 by x tends to 0. That means that denominator and numerator converted into 1 by x. It is very, very important. Whenever x tends to infinity is given, the given problem convert into 1 by x formation. Here 1 by x in the sense 2 by x I want, divide by x on both sides, x by x. Here 3 by x plus x by x, limit x tends to infinity. Now limit x tends to infinity, 2 by x plus 1 by 3 by x plus 1. Now here 1 by x, here also 1 by x. As x tends to infinity, 1 by x tends to 0. Therefore 0 plus 1 by 0 plus 1, it should be 1. Whenever infinity is given, the problem should be converted in the form of 1 by x formation. As x tends to infinity, 1 by x tends to 0. Now that is 0 plus 1 by 0 plus 1. Now this value is equal to 1. In one of the year in NCERT, they are given this question. Limit x tends to infinity, 2 plus x whole power 40, 4 plus x whole power 5 by 2 minus x whole power 45. You know the concept of limit extends to infinity. The total denominator and numerator changes into 1 by x formation. 1 by x in the sense we divided by x from this, and here x, and this is also x. Or we apply here limit extends to infinity 2 by x plus 1 whole power 40, or 4 by x plus 1 whole power 5 by 2 by x minus 1 whole power 45. We know that limit extends to infinity, 1 by x tends to 0. As x tends to infinity, 1 by x tends to 0. Now here 1 by x is 0, that means 1 power 40 is 1, and here 1 power 5 is 1, and here 1 power minus 40, here it is 0, minus 1 power 45. 45 is the odd number, therefore you should get minus 1. The value is minus 1. This is the process whenever x tends to infinity is given. Is one of the important model. And you see one more example of x tends to infinity. Limit x tends to infinity, root of 3x square minus 1, root of 2x square minus 1 by 4x plus 3. This is like the same way. Here x tends to infinity, we want to take the numerator and denominator to 1 by x formation, but here maximum is x square. Therefore, we divided by x square. Limit x tends to infinity, root of 3x square by x square minus 1 by x square, 2x square by x square minus 1 by x square by here 4x plus 3. That means divided by, or you take here 4x by 3 infinity. Now limit x tends to infinity. Here x square cancel, 1 by x square tends to 0, x square cancel, again 1 by x square tends to 0. Here also we divided by x, here 4 here divided by x square, 4 by x by 3 by x square. 4 by x plus, or you divided by x only, 4 plus 3 by x. Because in the square root part we take x square, only x will be there. That's why it should be x. Here divided by x square in the sense square root of x square means when you take x outside. Here 1 by x, here also 1 by x. That's why divided by x on both sides. Now here that is whenever we apply the limit x tends to infinity, 1 by x tends to 0, directly we get the answer. This is root 3 and this is root 2 by, and this is 4. Because 3 by x, 1 by x tends to 0. Here both the numerator and denominator is divided by x square only. But in the square root part, the denominator is x square, it comes outside, it is x. That's why the numerator is divided by, denominator divided by x. That is, there should be 4 plus 3 by x. That 1 by x is equal to 0, 1 by x square 0, and 1 by x square also 0. You get root 3 minus root 2 by 4. This is also one of the important model, or x tends to infinity model. Whenever the fundamental notation, when x tends to infinity, a naught x power m plus a naught x power m minus 1 and so on by b naught x power n plus b1 into x power n minus 1 and so on. The values, whenever x tends to infinity, a naught by b naught, if m is equal to n, whenever x tends to infinity, direct answer a naught by b naught, if m is equal to n. Here both the powers are same, then answer should be a naught by b naught. Whenever m less than n, if the numerator power is less than the denominator, the final answer is 0. Very important. Whenever the power of m is less than the power of n, that means numerator is less than the denominator, then the value is 0 whenever x tends to infinity. Or infinity when m greater than n where b naught greater than 0. In case m n కంటే ఎక్కువైంది అనుకోండి, the value is infinity. Whenever it is minus infinity, wherever m greater than n, b naught less than 0. Both are very important. If m is equal to n, powers are equal, directly they get the answer. If m is less than n, the fraction answer is equal to 0 whenever x tends to infinity. If m greater than n, the b naught is greater than 0. b naught is greater than 0. That means infinity is the answer. If m greater than and b naught less than 0, the answer should be minus infinity. These are the very, very important formula whenever x tends to infinity. By taking this, just one example here, limit x tends to infinity, ax square plus bx plus c by dx square plus ex plus f అన్నాం అనుకోండి, ది ఎక్స్టెన్స్ ఇన్ఫినిటీ అన్నప్పుడు ఏమన్నాం, ఇఫ్ ద పవర్స్ ఆర్ సేమ్ ద ఆన్సర్ షుడ్ బి a by d. దేర్ ఈస్ నో డివిజన్ ఆఫ్ ఎక్స్ స్క్వేర్ both numerator and denominator. If you divide x square on numerator and denominator also, here 0, here 0, 0, 0, we get direct answer a by d. If we check it, suppose when ax square bx square here only, just here 2 are same, b by d is the answer. Whenever x tends to infinity is given, the highest powers are same, then the answer should be the coefficients of that equal powers. Whenever x is m is greater than n, we get less than n, it is 0, greater than it should be infinity. This is x tends to infinity formation. Now just we discuss limit exist concepts. Limit exist concepts once we check it. Suppose fx is equal to cos x if x greater than or equal to 0. Again x plus k if x less than 0. I given here limit exist. Limit exists in the sense, you tell me whenever limit exists. If limit exists means x tends to a minus is equal to x tends to a plus. Left hand limit is equal to the right hand limit. LHL is equal to RHL. That means limit x tends to 0 minus f of x is equal to limit x tends to 0 plus f of x. 0 minus means left side, 0 plus means right side. Whenever LHL is equal to RHL, then function limit exists. Already the given limit exists. Here 0 means, if you take the condition here, 0 less, if x is less than 0, 0 కంటే తక్కువ ఉంది అంటే ఏ ఫంక్షన్ తీసుకోవాలంటే the function should be x plus k. Here 0 plus in the sense 0 greater than here. Whenever x 0 plus means the function you have to take, that should be a cos x function. Now we have to find the limit exists when the value of k. Now if you substitute x is equal to 0 here, 0 plus k is equal to, that is equal to cos 0. Cos 0 value is equal to 1. Therefore, the k value is 1. Whenever limit exists, find the value of k. Whenever they want limit exists in the sense, LH is equal to RHL. When given, see the given conditions and apply the limits, we find the value of k. And one more model for this, x square minus 1 and 2x plus 3, if 0 less than x less than 2, if 2 less than or equal to x less than 3, find quadratic equation whose roots are, limit x tends to 2 minus f of x and limit x tends to 2 plus f of x. This is one of the important model. Whenever the two functions are given, and find out the quadratic equation by using the roots x tends to 2 minus and x tends to 2 plus. As you take alpha limit x tends to 2 minus f of x. 2 minus in the sense, if you see the conditions here, 2 minus means 2 కంటే తక్కువ, x less than 2. 2 కంటే తక్కువ ఉన్నప్పుడు you take the function x square minus 1. Limit x tends to 2 x square minus 1, that is equal to 2 square minus 1. 4 minus 1 is equal to 3. Again you don't write here minus because this is the condition. Already from this condition you take the function x square minus 1. Therefore no need to write 2 minus here. Limit x tends to 2 is enough. And beta, limit x tends to 2 plus f of x. 2 plus in the sense 2 kanna equal. Here should see the condition here, 2 more and 3 less. Then you take the function limit x tends to 2, 2x plus 3 is the function. When I substitute here 2 into 2 plus 3, that is equal to 4 plus 3 is equal to 7. Now here 2 roots I observe, alpha is equal to 3, beta is equal to 7. We know the quadratic equation whenever alpha beta is given, x square minus alpha plus beta into x plus alpha beta is equal to 0. Therefore x square minus alpha plus beta 3 plus 7, that is equal to 10x plus alpha beta 7 into 3, 21 is equal to 0. This is the quadratic equation when alpha beta is limit x tends to 2 minus f of x and limit x tends to 2 plus f of x is given. Just find the quadratic equation. This is one of the important model whenever the limit conditions are given. Sometimes they are given the same notation, find the value of limit x tends to 1. See here the one problem, limit x tends to 1, 1 minus x plus x step x minus 1 plus mod 1 minus x. Sometimes they are asking this mod x and step x functions also. Here x tends to 1, find the value. Just we find step x minus 1 and mod x 1 minus x is given. If you take 1 minus 1, 1 minus and 1 plus, this type of problems already I told you the neighborhood functions of the given function. Neighborhood in the sense, if x is limit x tends to a minus, we should take a minus h. In the starting we discussed. Limit x tends to a plus, if you take a plus h. This is left side and this is right side. If you substitute in the place of x, we get the answers. Here I want to take limit x tends to 1 minus. Here 1 minus in the sense we substitute here in the place of a 1 minus h. That means in the place of x we substitute 1 minus h, 1 minus of 1 minus h plus here 1 minus h minus 1 plus mod 1 minus 1 plus h. Now implies here limit x tends to 1, 1 minus 1 plus h, minus 1 plus h plus 1 1 cancel here, step off minus h plus 1 1 cancel, that is mod h. Now limit x tends to 1, 1 minus 1 cancel, h plus step minus h plus mod h. Now it is equal to, or if you take x is equal to 1, 1 plus minus 1 plus 1, 1 plus minus 1 plus 1, or if you take x is equal, when you substitute a minus h 1 plus s, if you take x tends to 0, that is very important. It's not 1, x is equal to 0. And here 0, 0, minus 0. In the step is minus 0. Step is minus 0. Step function in the sense you take the previous values, because step x in the sense this is greatest integer function step x. If step 1.1 means only 1, greatest integer function. If step x is equal to minus 1, then step of minus 2, then previous least value is minus 2. In the same way here minus 0 in the sense that previous value is minus 1. If you take here 1 plus, if you take 1 minus, we get minus 1. If you take 1 plus, the same notation, but here in the step value we get h here. 1 plus means 1.1, 1.2, 1.3 later we get the value of 1. In this case, LHL not equal to RHL. LHL not equal to RHL. Left hand limit is not equal to the right hand limit. Then the limit does not exist. This is one of the important criteria, limit existence. By taking 1 plus h or 1 minus h whenever limits are given, just you check it like this, then LHL not equal to RHL, the limit does not exist. Is also one of the important model. Whenever you substitute a minus h and a plus h, it should be x is tends to 0, not equal to 1. And simply we know that in the previous examples, x square plus x by x, simply easily we get the answer. Direct procedures, cos x is equal to, these are the direct procedures. Whenever polynomial is given, if you substitute here x is 0, you take the factorization here, x into x plus 1 by x. Now limit x tends to 0, x plus 1, answer should be 1. Here directly cos 0 is equal to 1. These direct models may not be explained directly. Every student should solve these problems whenever polynomials are given. And one more important, limit x tends to 5 pi by 4 step of sin x plus cos x. In these models, we confused whenever step x is given. What is step x? Greatest integer function. Already we discussed in the previous sum. Greatest integer function. That means whenever you take 2.5, the greatest integer is 2 only. If you take minus 2.5, the minimum greatest is, that is minus 3. Minimum is minus 3. Maximum. Positive means greatest integer only. Whenever negative will be given in the step function, you take the previous one. Okay, here sin x plus cos x. The value should be 5 pi by 4. Step x is given. You convert into pi by 4 formation. Whenever you take root 2 here, x tends to 5 pi by 4. Root 2, 1 by root 2 into sin x plus 1 by root 2 into cos x. Very simple. Now limit x tends to 5 pi by 4. Here root 2, we convert, this is cos 45. Cos pi by 4 into sin x plus sin pi by 4 into cos x. Now we get one notation, that is sin a cos b plus cos a sin b. Sin a cos b plus cos a sin b, sin a plus b. Therefore root 2 into sin x plus 5 by 4. Sin x plus pi by 4. Now we substitute x tends to pi by 4 means in the place of here x value 5 pi by 4, we get the answer here. Once you check it here, root 2 into sin 5 pi by 4 plus 5 pi by 4, 6 pi by 4. You take 2 3s and 2's here. Root 2 into sin 3 pi by 2. Step function is mandatory. Step function is mandatory. Here root 2 into sin 3 pi by 2 times sin 270 is minus 1. Here step of minus 2. Minus 2 value 0.3010. 0.3010. This is minus root 2. We take step function here, we should get minus 1. Here minus 0 means the previous number is minus 1. Here step is very important. We convert into root 2 or sin a plus b, and finally we get 5 pi by 4. 5 pi by 4 plus pi by 4, 6 pi by 4, 3 pi by 2, that is 270. That should be minus 1. It is minus root 2, 0.3010 that value. Suppose it is minus 3, root 3, minus 1.732, value is minus 2 will obtain. This is one of the important model in limits substitutions. And one more important model, limit x tends to 0. Limit x tends to 0. X plus x square plus x cube and so on x power n minus n by x minus 1. See, this is x tends to 0. Here we directly substitute x is equal to 0, 0 minus 1 is equal to minus 1. But here n is given, not x tends to 0. We apply one notation here. I will explain after this problem. If x tends to 0, x plus x square plus x cube and so on x power n minus, I write n as 1 plus 1 plus 1 plus and so on n times by x minus 1. Then limit x tends to 0. If you take 1 from 1, again 1 from second one, third to third one, see x minus 1 plus x square minus 1 plus x cube minus 1 and so on x power n minus 1 by x minus 1. Now limit x tends to 0, x minus 1 by x minus 1 plus limit x tends to 0, x square minus 1 by x minus 1, limit x tends to 0, x cube minus 1 by x minus 1, and so that, and final one is limit x tends to 0, x power n minus 1 by x minus 1. Now limit x tends to 0, 1 plus, here notation is x power n minus 1 by x minus 1. Here x power n minus a power n by x minus 1, and the condition is 2 into 1 power 2 minus 1. Here 3 into 1 power 3 minus 1, and so on n into 1 power n minus 1. Now 1 plus 2 plus 3 plus and so on n, sum of first n natural numbers, n into n plus 1 by 2. This is the final answer. Here I used one notation here. Limit x tends to a, x power n minus a power n by x minus a is equal to n into a power n minus 1. That is very, very important notation. X power n minus a power n by x minus a is equal to n into a power n minus 1. We apply this condition here, then we get n into n plus 1 by 2. Wherever the necessary, we apply the formula, then you know the answer. Limits very easy when you understand the concept and you substitute or factorization or rationalization or limit existence, or they take common points. Whenever till 0 you substitute, we get 0 by 0 formations. Now we discuss only not indefinite formation, only finite say. If you substitute x value substitutions లో డిఫరెంట్ మోడల్స్ చూసాం ఇప్పటిదాకా. ఇప్పుడు దాకా మన నోటేషన్ ఒకసారి మళ్ళీ రాసుకుందామండి. లిమిట్ x టెన్స్ టు a, x పవర్ n మైనస్ a పవర్ n బై x మైనస్ a ఈజ్ ఈక్వల్ టు n ఇంటూ a పవర్ n మైనస్ 1. ద సేమ్ వే లిమిట్ x టెన్స్ టు a పవర్ x పవర్ m మైనస్ a పవర్ m బై x పవర్ n మైనస్ a పవర్ n ఈజ్ ఈక్వల్ టు m by n into a power m minus n. Limit x tends to a, x power m minus a power m by x power n minus a power n is equal to m by n into a power m minus n. If you take x tends to a, for example, x cube minus a cube by x square minus a square. The same notation here. What formula? M by n into a power m minus n. This is m and this is n. 3 by 2 into a power 3 minus 2. That is equal to 3 by 2 into a. Answer is 3a by 2. Whenever these two formations are given, we apply in the previous sum also x power n minus a power n by x minus a. That is equal to n into a power n minus 1. Or if we substitute a here, a minus a is equal to 0. Indefinite form. L'Hospital we apply by taking factorization or differentiation. X power n differentiation is n into a power n minus 1. Directly we get the answer. Here also m into a power m minus 1, n into a power n minus 1, we get m by n into a power m minus 1. Whenever we substitute x value, numerator and denominator is 0 by 0 formation, we apply L'Hospital also, we get